Okay, so today we're going to be discussing injectors for direct injection hydrogen diesel engines. Now, forgive my nose is slightly plugged up, so forgive that. So the main difference between a hydrogen injector and a conventional liquid fuel injector is really twofold. The first is that pressurization in the injector itself is actually not required. So on many diesel fuel injectors, in fact on most, the common rail, the feed pressure is lower than the final pressure. So the plunger pushes down on the fuel and pressurizes it to a much greater degree than what the incoming feed pressure is for that final atomization. On a hydrogen injector, it's not really necessary to do that because your goal is not to atomize it to these insanely high pressures, to these extremely high pressures. All that's needed is a pressure above the cylinder pressure of the engine. So the peak cylinder pressure on a diesel engine can approach like between 1,000 and really high end, maybe 2,000 psi, but typically it's going to be somewhere around 1,000. And so under high load, it will increase, and with with hydrogen diesel engines, it's going to increase more so. Cylinder pressure is going to be higher because of the higher laminar flame speed of hydrogen. Hydrogen essentially just burns a lot faster, and so the cylinder pressure rise will be greater. But nonetheless, we want a certain margin above that peak cylinder pressure, obviously, so that our gas is actually able to penetrate through. And so in that case, we'd probably want a pretty good margin, something like 30% over the peak cylinder pressure. And so the reason why in some ways the injector design is actually simpler is because if you have a high pressure tank or even a liquid tank, the feed pressure can be very high. You don't need to pressurize it. If you have a liquid tank, you just basically let it boil off, you vaporize it, and it's going to expand, and essentially you'll get free pressurization. You won't need to pressurize it. So if you're using ammonia cracking, and that's something we're very interested in, then of course you will need to pressurize it. So, or of course if you have a stationary engine and it's feeding off, say, a low pressure hydrogen pipeline, say from a wind farm that's producing gaseous hydrogen, it's fed into a pipeline, or you can imagine just situations where you're running it directly off an electrolyzer. I mean, not that makes much sense, but in many cases you're not going to have high feed pressure, so you can go ahead with you're going to have to design some kind of injector that's actually going to be able to pressurize it, either at the injector itself or prior to the injector, so you have some kind of compressor. Again, these are choices these are all usable options. You just have to choose from them. So we're designing injectors that are going to be non-pressurizing, so they're just basically valves. So basically, you essentially just an on-off valve. So the plunger serves as a closing and opening, essentially shutting off and on the flow of hydrogen into the injector, but it also serves as regulating that flow each time it comes up. So each time the plunger comes up, it moves up a little bit more or less, determining the rate of flow, determining the throttle of the engine. So the other advantage with hydrogen, or in fact with gas, that or in fact actually uniquely in our engine, we don't have to worry about injection timing as much, because the goal of injection timing is mainly utilized to reduce emissions, and so of course we eliminate the need to reduce emissions because we have no emissions. So we can just basically design the fuel injection pattern purely for performance and also practicality. We don't need really fancy injection timing, so we can have just one spray instead of multiple sprays. Again, it makes it simpler, a lot simpler in terms of the injector. The ECM would have to be rewired if you were to convert an electronic engine or a mechanical engine, or the engine could actually be converted to mechanical to reduce the amount of money needing to be spent on the conversion, because actually remapping an ECU would be quite expensive. Might not be worth it, because again, old mechanical engines are not less efficient; they're less powerful, and they have higher emissions. So if you take an old, if you look at an old 1980s, say high compression diesel engine where they had these much higher compression ratios than you have today, like 22-to-1 maybe, and it has a swirl chamber, so it's indirect injection. Those engines are not that much less efficient than modern diesel engines. They do produce less power output per they're not as power dense, but they have lower power output, but they're not that much less efficient, and they have again one spray mechanical injection systems. And so with hydrogen, you're kind of changing the whole injection system paradigm. I mean, most of the kind of effort into designing the injection system is to minimize. A lot of it has to do with minimizing NOx. So, I mean, if you're familiar with our system, there's actually no exhaust, and so something that people are not familiar with. But there's actually no incentive. Of course, you want to just basically run the engine as you want the highest combustion temperature possible, because that's what's going to lead to the highest efficiency. Whereas current engine designers want lower combustion temperatures. And so NOx formations increase dramatically above about 2,500 degrees Fahrenheit. And so engine designers are really incentivized to reduce that temperature, but by doing so, you're going to get less efficiency and less power. So, the injection systems are not going to fundamentally change. One issue is embrittlement. Embrittlement is actually somewhat of a problem for hydrogen injection systems, but that can be mitigated by using special coatings on the inside of the injector. So, high density ceramics or possibly even epoxy can be used, provided it's not in the high temperature region. So in that case, you would use ceramics. But the thing is, injectors are actually not that expensive, and so if you have shorter life due to embrittlement, you would just be able to increase in the injector replacement intervals, and it's not going to add a big significant effect on operating costs because injectors represent maybe 1% of the cost of diesel engine. So, I mean, replacement fuel injectors for mass-produced diesel engines cost $100. So if you take like a unit injector on a Volkswagen TDI, that injector costs $100. And so you have 4 of them, and you have to replace them every 5 years. It's so insignificant that it's not even worth paying attention to. But of course, if you have smaller production volumes, you have you're manufacturing these custom hydrogen injectors in the immediate term, they will be more expensive. And so we would want to develop them to be resistant to embrittlement. One way to deal with embrittlement is it's not to use metals that are susceptible to embrittlement. We know that stainless steel, Inconel, mostly ferrous metals, especially carbon steel, even titanium, are all very susceptible to embrittlement. We know aluminum is very resistant to embrittlement. I'm not an embrittlement expert, but one of my Twitter followers is actually a professor, and he's specialized on his expertise in embrittlement. And so I'd have to ask him, reach out to him, and ask him what materials are most suitable. But I mean, I know it's typically something that's not metal is most attractive, and so I would imagine something like developing a high density, a very strong high density, wear resistant, non-metallic material to line the inside of the injector with, and so that could be a really effective way to minimize embrittlement. Now, there are issues with injectors. Of course, it is a gaseous fuel, like a natural gas injector is the same. So you don't have lubrication, and so that means that you're going to have external lubrication. Again, not provided by the fuel. A lot of fuel injectors, actually most diesel fuel injection systems, are lubricated by the fuel. Not that an injector needs a lot of lubrication, because it's essentially just a plunger that goes up and down. It's not requiring that much lubrication, but that's something to pay attention to. But overall, hydrogen injectors have been designed and built and tested to be perfectly feasible. This is not like this novel technology. I think the hydrogen injectors have been designed. Again, the reason we don't hear much about hydrogen injectors is because no one's working on hydrogen diesel engines, or for that matter, hydrogen engines in general. So